Hello students, today we'll start a new chapter, Refraction through a lens. Lens is a transparent refracting medium bounded by two spherical surfaces or one surface spherical and the other surface plane. There are two kinds of lens, convex or converging lens and number two, concave or diverging lens. A convex lens is thick in its middle and thin at the end. In other words, a lens which bulges out in the middle is a convex lens. A light beam converges on passing through such a lens. It is also called converging lens. A convex lens is of three kinds. Number 1, biconvex lens or double convex lens. Number 2, plano-convex, and number 3, concavo-convex lens. A biconvex lens has both its surface convex, this side and this side. Both surfaces are convex lens. A plano-convex lens has one surface plane and the other surface convex, while a concavo-convex lens has one surface convex, this surface convex, and this surface is concave, such that it is thicker in the middle as compared to its ends. A concave lens is thick at its end and thin in the middle. In other words, a lens which bends inward in the middle is a concave lens. Such a lens diverges the light rays incident on it, so it is also called a diverging lens. A concave lens is of three types. Number 1, biconcave lens. Its both surface is concave. Both the surface is concave and hence it is called a biconcave lens. A plano-concave lens. One side it is plane and the other side it is concave. And the third one, convexo-concave lens, has one surface concave and the other surface convex. One surface concave and the other surface is convex. So both concavo-convex lens and convexo-concave lens have one surface convex and the other surface concave, but they differ in their shape and action. A concavo-convex lens is thicker in the middle and has a converging action of light beam, while a convexo-concave lens is thinner in the middle and has a diverging action of the light beam. Now, action of the lens as a set of prism. We have just now read that the refraction of light through a prism in the last chapter. Now, refraction of light through a lens can also be understood in a simple way by considering the lens as being a part of set of prism. So to make it further simple, the prism is in the center of the lens as shown in the figure is treated as rectangular slab. This at the center, this is our rectangular slab, and at the edge, the lens is considered being a part of a rectangular slab at the center and one prism on the either side. Here we have one prism and one prism here on the either side of the lens. So, a convex lens in its upper part has a prism with its base downward. Here the base is down, both the sides, the base is downwards, and in its lower part has a prism with its base upward. On the other hand, a concave lens, its upper part has a prism with its base upward. Here the base is upward. The base of the prism is upward, and this like this the prism is head point is the angle is A is towards downward. Here in this diagram also concave lens has base of the prism as upward, and here the base is towards the downward. This is the base of the prism. Now, when a ray of light coming parallel to the principal axis on a convex lens. Now the converging action of a convex lens, suppose this is a convex lens and it is a prism, and middle part is a rectangular slab. At the edge we have two prism. So how the converging action of this lens happens? Suppose we have three incident ray A, B and C incident on the prism in the upper, central and the lower part of the convex lens. We know that a ray of light incident on a prism, the refraction through its always bends towards the base of the prism. The refraction always bends towards this. Suppose this is the base, so the refracted rays base towards the bend. It bends towards the base of the prism. This is the base of the prism, and just it happens to the ray C also. It bends towards the base of the prism. The central part of the parallel side, that is the glass slab, passes. This ray will pass undeviated. Thus, the set of the prism forming a convex lens converges the parallel ray to a point F. At this point, all the rays comes and converge at a point. Therefore, a convex lens has a converging action on the incident light of rays. Now, diverging action of a concave lens. Suppose we are considering the same way, three incident rays A, B, C. This ray B will pass undeviated because it is a glass slab, the central part. So it will pass undeviated. Thus, a set of prism forming a concave lens diverges the parallel ray. What happened here? The ray A, when it is coming and striking this prism, its base is towards this side. So, refraction towards the base. Similarly, it happens to the ray C also. Refraction towards the base. So, it diverges. Both the rays are diverging away from the prism. The set of prism forming a concave lens diverges the parallel ray as if they are coming from a common point F. Now, some technical terms related to the lens. The very first is center of curvature. A lens has two surfaces. Each surface of the lens is a part of a sphere. So the center of the sphere, whose part is the lens surface, is called the center of curvature of that surface of the lens. So a lens has two spherical surfaces. So there are two center of curvature of a lens, C1 and C2. The two spherical surface, the lens is the part of this sphere and this sphere. So it has two center of curvature, C1 and C2. Now radius of curvature. The radius of sphere whose part is the lens surface is called the radius of curvature of that surface of the lens. Similarly, PC1 and PC2 are the two radius of curvature of the two surfaces. If the lens is thin, then PC1 is equal to OC1 and PC2 is equal to OC2. So, the radius of the thin lens, the radius of curvature of the surface of the lens is equal to the distance of the center of the curvature of that surface. So, this is our radius of curvature. Now, next is principal axis. It is the line joining the center of curvature of the two surfaces of the lens. So, this line is our principal axis. Similarly, this line, the line joining the two center of curvature is the principal axis. Now, next term, optical center. It is the point on the principal axis of the lens such that a ray of light passing through this point emerges parallel to its direction of the incident. It is marked with the letter O. Optical center of a thin lens is the point on the principal axis of the lens such that a ray of light directed towards it passes undeviated through it. Now next is principal foci. A ray of light enter a lens from either side Therefore, a lens has two principal foci, and it is called first focal point and second focal point. First focal point. For a convex lens, the first focal point is a point f1 on the principal axis of the lens, such that the ray of light coming from it after refraction through the lens becomes parallel to the principal axis. The ray of light which is coming from it after refraction becomes parallel to the principal axis. This is our principal axis and these two rays are parallel to it. So this is the first focus. For a concave lens, the first focal point is a point f1 on the principal axis, such that the incident ray of light appearing to meet at it after refraction from the lens becomes parallel to the principal axis. So they are appearing to meet from it. This is our first focus. Second focal point. For a convex lens, the second focal point is the point f2 on the principal axis of the lens, such that the ray of light incident parallel to the principal axis after refraction from the lens passes through it. And for a concave lens, the second focal point is the point f2 on the principal axis of the lens, such that the ray of light incident parallel to the principal axis after refraction from the lens appears to be diverging from this point. This is our first focus point and the second focus point on the principal axis. Now next is focal plane. A plane normal to the principal axis passing through the focus is called focal plane. This is the focal plane. A ray normal to the focus point passing through the principal axis. First focal plane and second focal plane, two focal planes are there here in a lens. A plane passing through the first focus point and normal to the principal axis of a lens is called first focal plane. A plane passing through the second focal point and normal to the principal axis of the lens is called second focal plane. Now next is focal length. The distance of the focus from the optical center of the lens is called focal length. Here also two focal lengths. First focal length, the distance from the optical center of the lens to its first focus point f1 is called the first focal length, denoted as small f. This is the focal length, the distance from the focus to the optical center. Similarly, second focal length, the distance from the optical center of the lens to the second focus point f2 is called second focal length. This is our focal plane, which is normal to the principal axis in a convex lens.